The Millau Viaduct in France is a work of engineering virtuosity. It's over 8,000 feet long and taller than the Eiffel Tower. For engineer Michel Villajour, building this gargantuan structure is the challenge of a lifetime. Michel's biggest challenge? Figure out a way to move the bridge's 1.5-mile steel deck from the staging area out into the open air, high above the Tarn Valley.
It was necessary to create a system where the launching force was created pier by pier in such a way that no force, no bending was produced in the piers.
Called a translator, the machine uses the slipperiness of PTFE and hydraulic jacks to lift the deck off each pier entirely before moving it deeper into the valley. Each translator uses 2 wedge-shaped blocks coated in PTFE. A hydraulic ram pulls the upper wedge, which slides it up the lower wedge. This lifts the deck away from the pier, pushing it forward at the same time. The lower wedge then slides backwards, lowering the deck back onto the pier. Each cycle moves the deck approximately 2 feet. 7 temporary piers are built across the valley. But as the 1.5-mile deck is pushed out into the void, the course is not straightforward.
Here, from the north abutment, we can first see the curve of the bridge. The bridge is curved with a radius of 20 kilometers, which is very, very large.
As the 2 colossal sections approach each other from opposite sides of the valley, engineers rely on GPS technology to ensure pinpoint accuracy. "15 months after the first attempt, the 2 sections of deck finally meet above the Tarn Valley. And incredibly, they're only off by a few millimeters.